Hello and welcome to our outdoor cat tracker poster presentation. For the approach to track the cats outdoors, we first have a GPS tracker mounted on the LoRa radio transceiver on it, which will send the GPS data back to the cat's house. This will receive the data, this home base will receive the data and use the internet to upload the position to our backend server. Then the application will use the data from the backend server to track the cat. Some of our motivations are that outdoor cats may wander or get lost, and owners could get stressed not knowing where their cats are, or they might keep their cats indoors when the cat really wants to go outside for fear of losing them.
So the hardware design that we came up with includes the GPS, the radio, and a battery, along with a voltage regulator and a USB-C charge circuit, as well as a 1 decibel ceramic patch antenna that was all picked to be lightweight and carryable by a cat.
Okay, so for software architecture, we are focusing the tech stack we have being React Native is building the mobile app for real-time user interaction and user experience. And then when we have the Expo, which is the streamline of React Native development, where we can see the prototype of the app in real life. Here, for example, you can see for screen is home, live map, outer screen, and setting. And then the Firebase authentication is where we manage the user login, and then managing the database for the pet, which we can store the radius for the geofence design. And then the last one is the Flash API, where we receiving the endpoint for the front-end app, where we can see the location, the time, update every 10 seconds.
So in testing, we tested in Pickering, where we were able to simulate both in a forest and a suburban environment. In suburbia, we were thankfully able to achieve 1 kilometer of range, which was more than enough for a cat. And this was a test suited for our clientele, more so our clientele, which in North America, most people live in suburbs. So this was perfect reachability. Meanwhile, in the forest, we only achieved 200 meters, but that was because of a bunch of trees, and we believe that it's not as realistic for where a cat lives generally. Lastly, we did with our test in the forest, we did test against the Apple AirTag, a competitor, and the Apple AirTag only achieved 30 meters against our 200-meter range from our CatTracker. So we can conclude that the CatTracker is vastly superior to the Apple AirTag.
To wrap up, our project successfully delivered end-to-end IoT tracking system with real-time data, back-end integration, and mobile-based visualization. Moving forward, we hope to expand the system by adding the battery level monitoring and supporting indoor localization and tracking capability. I would also like to thanks to Miranda Salem, who is our professor, for her guidance, for the support throughout this project, as well as everyone who contribute along the way in and out of TMU. And don't forget to also check out octtmu.netlify.app for our capstone showcase website, where we have more information about the capstone, the user story, the team, about the team, about the specification, and then also the project timeline as well. So once again, thank you for this valuable experience hosted by Toronto Metropolitan University.